let's solve this problem called merge sorted arrays. Now let's understand how to solve this problem. So basically you are given two integer arrays nums1 and nums2 sorted in non-decreasing order. Let me explain what is non-decreasing order. Let's say for example I have 1 2 2 3. This basically 1 2 3 is a ascending order. If I have 1 2 2 3, this is non-decreasing order because we cannot call it exactly ascending order or increasing order because there are duplicates. That's the only difference in non-decreasing and ascending order. Rest all will be same. So and two integers m and n representing the number of elements nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. The final sorted array should not be returned by the function but instead be sorted inside the array of nums1. To accommodate this, nums1 has a length of m plus n where the first m elements denote the elements that should be merged and last n elements are set to 0 and should be ignored. Nums1 has a length of n. So if we see this, nums1 and nums2, there are three elements and three placeholders where we can merge. That is what the question is all about. We don't have to create a result, but we just have to replace this. So let's discuss a simple solution first. We all know that. So basically let me copy this. We are given these two arrays. Let's say for example I also have a result array, and now I know I'll keep checking the elements. Let's say 1 and 2. Which one is smaller? 1 and 2 and 2. We can consider any one of them because they are equal. Let me consider this one. And 2 and 3. I know that 2 is smaller, so let me add 2. And then 3 and 5. What is the difference? 3. And 5 and 6. There are no numbers left in this array because these are all placeholders. Now I just have to copy the remaining elements 5 and 6. This is how we generally do, and we can copy the result into, like, all the elements of result into nums1. That we can do, but we are kind of wasting an additional space of m plus n even though we are not going to return it. So we can have a better solution without wasting this space. So the trick for that is, let's say instead of me copying elements from the beginning, can I do something from the end? Let's say I start comparing elements from the end. 3 and 6, which is larger? 6. So let me replace it. And now 3 and 5, which one is larger? 5. Let me do it. 3 and 2, which one is larger? 3. Right. Now let me compare 2 and 2, which one is larger? 2 is the element. 2 is the same, right? So I can take any one of them. Let's say 1 and 2. Again 2 is there, 2 is being copied here, and 1 is there. This is how it looks, right? Let me also take one more example which we are given here. Nums1, nums2. So basically if we check here, nums1 itself is present and nums2 is not present at all, and this itself will be the answer. We don't have to worry about it. And yes, this is little tricky. They have given 0 as a placeholder, but the length is m. So we just have to copy this element into nums1 and we just have to return it. So let's write code for the same. So what can we do? We can apply the two pointer technique here. Let p1 be m minus 1 and let p2 be n minus 1, right? And let index where we are going to start storing our result be m plus n minus 1 because I am going to start at the last index where I'll start storing the elements. So now what should I do? I have to check if the pointers are valid. So that I can do by checking if they are greater than or equal to 0, because the upper bounds are already defined by us, they are not going to go beyond that. So now let's say nums1 of p1 is greater than or equal to nums2 of p2. Let's say when I am here, nums1 of p1 is less than this. So we will come back to this condition. So what do we do for this condition now? We are going to copy nums1 of index, like we are going to copy nums2 of p2, right? Because p2 is larger. But the other case, what will we do? We will copy nums1 into the nums1 array in the index. We also know that when we kind of copy, we have to change our index and also the pointer p1. Here we are changing the p2 value, so we are going to reduce the p2 and also index. Now there would be a case, let's say for example there are elements left out in p1. We don't really have to worry about them because they are already sorted and they are in the same array. But if there are elements left out in the array in the nums2, what we have to apply the same logic. p2 is greater than or equal to 0. We just have to copy nums1 of index equal nums2 of p2, all the elements in the array. Now we have to decrement the p2 and also the index, right? And we don't have to return anything because this function is a void type, and this should solve the problem. Let's try to run it first. Okay, let's also submit it. Yes, we are able to solve this problem. So basically this technique is called as two pointers, and we kind of are using the logic where we start from the ends because we are aware that the initial, if we start from the beginning, the initial pointers will be overridden, but if we start from the like in the descending order or non-decreasing, like non descending order, what will happen is that we kind of replace these placeholders and we still have the value of our pointers. That's the trick here. Thank you.